Hello and welcome back. We started last time with looking at gel electrophoresis. Here we see a micropipette placing a sample of DNA in the first well, and like we mentioned last time, this could be of known DNA called ladder DNA, which acts as a marker to compare our other DNA samples with. In the second well, we could put DNA found at the crime scene. In the next well, suspect number 1, and in the last well, suspect number 2. So as mentioned last time, DNA is always negatively charged, and this is because of the phosphate group, and it always moves towards the positive electrode. DNA moves according to weight. So the heavier DNA fragments will require more time to move towards the positive electrode, and the smaller fragments will move much more slowly. So they're separated by size, and we can compare them. So as I mentioned, we have a marker in one of the wells that is from known DNA, and it's already known the weight of each of its DNA fragments. And so this allows comparison with basically the 3 segments that we have. We also need to put a dye into the wells. Now, this is not to stain the DNA, but it's to allow us to see the progress of the DNA samples. And this dye is also negatively charged, and that allows it to move towards the positive electrode. Okay, so imagine we have some DNA from a crime scene, and these are the fragments. Which suspect is this from? Well, it's pretty clear that it's suspect 2 here. So to compare DNA in this way is pretty easy. Something that is slightly more complex is, imagine I am a mother and this is my DNA strand. It's basically what has come out of the gel electrophoresis. These are the weights of the fragments of my DNA. And imagine I have a child, and these are the fragments of the child. Some of my fragments will match up with those of the child, such as this one here. It's the same weight, but I don't have one that matches up here. Therefore, the dad of this child must be either number 2 or 3, because we have those that match up here. So we now need to look at other fragments. So the child has one here. Dad number 1 does, and so does 2, but 3 doesn't. But we've already said that we can't have dad number 1 being the dad of the child, so therefore it must be dad number 2. And we can check that each one of the dad's fragments is found in the child, unless the fragment is in the mother. So this fragment here, the second one on dad 2, doesn't match up to the child. But the child altogether has fragments that have either come from the mother or the father, dad number 2. There's no other fragments that are contained there. So I hope this gives you an idea of how paternity testing is performed. I hope these 2 videos have been useful to you. Let me know anything else you'd like to know, and see you next time.